Hello and welcome to my final project. This is Zach Mitchell, and I'll be narrating for you some slides here as well as some video of me attacking my home network. This is a WPA1 network. Um, it's just your regular run-of-the-mill Comcast home router, and I will be using some techniques, deauthentication attack with a brute force word dictionary to get my password for my home Wi-Fi. So yeah, let's go ahead and jump in here. Our goals today, we're just going to discuss a few tools. I use 3 tools. We use Kismet, Aircrack NG, and Wireshark. All of these are Linux tools and available on some other operating systems as well. I use them all to get this password. And from there, I'll walk you through the actual attack, and we'll just discuss kind of in theory too how it happens, like what is happening. And then we will crack my password. And then after that, we will discuss how I crack my password using this brute force method. Yeah, and finally, after done with all that, we'll just very quickly cover how we can defend ourselves against this sort of attack going forward. So before we jump in, I just want to give a bit of a warning. Everything that we're going over here today, since January 2015, it's illegal to do it to other people. You can break into your own network, which is what we do here, but do not do it to other people. If you want to read more about it, I've provided a link here, and yeah, you can toe the line or not, however you see fit. My fair warning. But yes, the first tool that we'll be using is one of my favorites in this project is Kismet. They've completely redesigned the interface, so right now it's kind of in beta, kind of buggy. In the documentation they have mentioned that there are some memory leaks and some weird crashes, but we'll see that and we'll work around it. So what it is it's just a network detector, packet sniffer. Really, it just does it all, but really what's special about it is that it's completely passive, so it sends no packets out. So this means it's pretty much untraceable, and it's a great tool just for sniffing any sort of network traffic that is happening at all around you. And yeah, you can see here I've added the command that you would run in terminal just to download it to your system, or if you want to go to the direct link, it's here as well. Our second tool is Aircrack NG. Aircrack's another nice tool. It's another packet sniffer, but not completely passive. It can also inject packets too, and it has some tools that we will use to crack passwords. We'll use it to crack a WPA password. And then finally, Wireshark. This is a packet analyzer tool, just allowing one to look at any information that gets passed within earshot. Anything that crosses your network interface's path, you're going to be able to look at it. So that's pretty cool. So yeah, we'll just jump right in here, talking about a deauthentication attack. Basically, overview of what that is. Deauthentication attack is essentially just disrupting service between a Wi-Fi router and a device that's connected to it just momentarily, disrupting service, like yelling really loud in order to make that connection break apart. And once they break apart, they try to reconnect, and upon reconnecting, that is when we get some information from them, which we will use to crack a password. So yeah, just kind of an overview chart. This is from Wikipedia. This is what initially happens. We have the authentication, the two joining together, and some data is passed long before the attacker comes in here. And basically what the attacker does is he floods the AP, which is the router access point, and the client. He floods them with packets saying that they are from the other. So the attacker will send a bunch of packets to the client saying it's from the router, and the attacker will send a bunch of packets to the router saying it's from the client, and it overloads them essentially, and they disconnect. So it only just takes a second or two to do this, but it's highly effective. From there, those two devices, they hook back up, they do the four-way handshake, and then we grab that handshake. And that's what we'll do here. Hello and welcome to my computer, or actually my two computers. All these commands that you're going to see, all this action, hacking, took place on my Linux computer. However, because Mac has better video editing capabilities, I transferred this over to my Mac. So if anything looks odd, if you see me switching between screens or some things popping up or two mice on the screen, that is because there are two computers active. But yeah, hopefully that doesn't throw you off too much. So down here in the blue, I have listed my terminal commands. If we can't see them in the terminal on the screen very well, I'll make sure that you can see them nice and bold down here in blue. So let's go ahead and get started. So yeah, I'm going to launch my terminal. First program I'll run here, and what I'm going to start off with is I'm just going to run my program Kismet just by itself. We're not going to pass it any arguments. We're just going to run this program Kismet, which is just a passive packet sniffer. So it's just going to intercept packets that it hears on its network interface. So where I'm going right now, I'm going to localhost 2501. That is the address you can see at the bottom there in my terminal that it wants me to go to see the interface. And right now it's not much good to us because we have yet to define the network interface that we're going to be listening on. So in order to do that, on Linux, we're going to go ahead and type in this right here, this IP link show. And what that does is it shows us, as you can see in my terminal, all the different network interfaces. And if you're not sure of which one you want to listen on, that's all right. I have another command here, this lshw-class network. This is going to tell us what each of those do. So yeah, you see me highlighting right here. This is the wireless interface. This is the one that we actually want, that WLP1S0. And this is my Ethernet interface. And so yeah, I'm going to make sure that I copy paste that wireless interface. I'm going to put it in a note here. And we're just going to keep a few notes. We're going to need to save this for later. And now that I have my network interface, I'm going to pass it to Kismet as a flag, and we're going to say start listening on this wireless interface. And now it's starting to run properly. We're going to refresh the web interface. And now here we go. We have some action. Here we can see, just a ton of Wi-Fi devices. In here we can see, how many packets they're sending, if it's a Wi-Fi device, if it's a Wi-Fi AP, like an access point, like a router. And we have a lot of options, like we can see which ones are actually active. So I'll just highlight only the ones that are actually sending and receiving packets. That's really all we care about here. And we'll go ahead and save that. And beautiful. Looks like we have a lot of activity around us, and this is everyone around me. This is my neighbors, my devices, their devices, anybody within earshot. And I click on my network here, this home 55E2, and I want to look at all the devices attached, and I only see 3. I should have much more, to be honest. And I think the reason why they're not showing up yet is because Kismet, I have kind of just made it so it's listening across every channel everywhere. And as you can see here, it's just hopping from channel to channel, just listening to everything from everyone. Really, I just want it to be a little bit more targeted, though. Just listen on my channel. So right here, you can see I just want channel 1 is all I want. Yeah, so we're going to stop Kismet one more time, and just so we don't have so much information, we're going to say only listen on channel 1, do not hop channels. So the command I'm putting in right now, right here, this Kismet-C WLP1S0, that's the channel. And then I put these flags, don't channel hop, that's false, and just stay on channel 1. All that there. Alright, and so now I refresh again. I only have channel 1 devices. Again, I still am going to have stuff probably from my neighbors. If they're on channel 1, anybody on channel 1 is going to be here. I click on My Home Wi-Fi again. I take a look at the devices attached to it. And wonderful, I have much more. And this is the device I'm actually going to kick off my network. This is my iPhone. And you know, that's how the deauthentication attack works. Basically, I kick off my iPhone from the network, and then what's going to happen is it's going to reconnect back to my router. And when it does that, it's going to do a 4-way handshake, and from that handshake, we are going to decrypt my password. So what I'm doing right now is I'm just writing down some information about my network. Here I've put down the home 55E2, that's my network name. We're going to need that later, as well as the MAC address for it, so the BSSID for my AP, that's the access point, it's my router. And then we need that MAC address from my iPhone as well. We're going to write that down just to make sure that we tell this next program which one to kick off. And I just want to take a look and make sure that all these devices attached here are mine. You know, you can see the manufacturer and all that. That's pretty neat. Nice. And yeah, all I care about again is just getting that handshake between my phone and the router. So we are going to deselect all this blue highlighting, all these other active devices. All we want is this WPA handshake. So we're going to save that. And we're actually going to open up another program here. It's called AirCrack NG. And this is the program that we're going to use to deauthenticate my phone from the network. So what it's going to do is it's basically just going to yell really loud just for a second, and it's going to disrupt the connection between my phone and my router. And upon doing that, you know, they'll reconnect, and upon reconnecting, that's when we'll grab that handshake, and then we'll be able to decrypt the password. So you see me here, I'm passing sudo airplay ng, that's the call to the program. Deauth, I want to deauthenticate. I pass 5 because I only want to send this packet sequence 5 times. A is the router, and C is my phone. And then I again define the network interface. So this is what I pass to it here. And I'm taking a screenshot of my phone just so you can see that this is effective. You know, it's going to just show that, you know, I'm connected to Wi-Fi, and then once I run the attack, it'll show that I got kicked off of Wi-Fi. So here I am putting in my password to run it. And blam. So yeah, a lot of activity there. You see on the far right hand side of that terminal window that's running that, you know, see a bunch of zeros, and to the right of that pipe, some numbers. That's how many that are actually getting through to the device. So the 0 means my device is no longer listening. And then you see over here red. That's perfect. That's exactly what we were looking for. The red indicates that, you know, we sniffed a handshake, and that's what we've been after this whole time. So now that we have that handshake, we just want to download, you know, only those 4 packets. So luckily Kismet just has this ability to do just that. You know, we've throughout this process sniffed thousands of packets from, you know, my devices, from my neighbors' devices, but we only just need 4. So what I'm doing right now is I'm looking for just those 4 packets. Kismet has a nice little feature where you can just download those. And so I pull it up here, and yeah, you can see WPA key exchange handshake packets 4, and I should be able to just download these PCAP files, you know, to do my decryption. But I think just because this is a beta version, that whenever I click to download it through this interface, it, you know, kills the program. So obviously that's not intended. I'll make sure that I send a bug report or maybe adjust my system. I'm not sure yet what's causing that, but Yeah, what we need to do now is we need to sift through those thousands and thousands of packets just to find those 4 packets in order to decrypt my password. Luckily, I have a workaround using Wireshark in order to do that, so that is what we will cover next. All right, so we are back now where we left off. We had a bunch of packets. We had thousands and thousands of packets, but we only need 4. We just need the 4-way handshake, which are in 4 packets. So in order to do that, we are going to use a program called Wireshark in order to sift through those packets. And I'm going to begin here just closing out that broken page, and I've taken my Kismet log, basically logs everything that happened, all those packets, and I just put it on my desktop to easily find it. And so what I'm going to do now is I'm going to move this packet. I'm going to move it into I'm going to move it into a folder where I have some tools in order to, take this packet and make it into what's called a PCAP file. And with that file, I can open it in Wireshark, and we can just get those 4 packets that we need. All right, so take a little trip here through my directory tree. We're in our Kismet folder. We're in the log tools, and you can see here I've put my Kismet logs inside this folder, and we are actually going to use this Kismet log to PCAP Python function here. Nice little handy function. And we're just going to transform this into a PCAP file. So I'm going to change the directory here. Oh, yeah, I'm going to change my working directory into this log tools directory. And then I'm going to call this Python file. If you look here, we have kismet underscore log underscore 2 pcap.py dash in. You have to define the in file, and so it's this kismet in file. And then you just name the out file. I named mine handshake.pcap. And so, perfect. Now I have 60,000 packets in that PCAP file. We're just going to move it out to the desktop again just for ease. And I'm launching Wireshark. And with Wireshark, we're just going to get those 4 packets that we need. So I'm going to open up this PCAP file, and we'll see here, all 60,000 packets here. This is my neighbor's activity. This is my activity. Just anything that this sniffed, it's in here. So I'm sure there's some stuff in here that I probably don't have right to be viewing, and I'm not going to spend any time looking at that. But yeah, what I want to do is I just want to find those 4 packets. An easy way to do that is to just filter out using this EAPOL. And so it's filtering out of all those 60,000 packets, here are the 4 that I need. And you can see there's the source destination. That's my router. That's my phone. They had a little conversation. They shook hands. And we just want to take a look at that conversation. So yeah, I'm just kind of taking a look, a deeper look at the packet. We'll see here the nonce, and this is just basically a hashed out key, encrypted. We don't yet know what it means, so we'll talk about that here in a sec. But yeah, Wireshark's great for seeing all that stuff, and we're just going to export these 4 packets into a PCAP file of their own. We're just going to name it handshake.pcap. See, just those 4 packets, that's all we need. All right, put it there on the desktop, and we can close Wireshark. We're done with that. And we are going to use another tool from Aircrack NG again. this is a decryption tool. Now that we have that handshake, we're just going to compare it to a file of, I think there are 14 million different passwords in it, and this is just a word list of common passwords, and we're just going to compare it to that, and it's going to decrypt the password with it. Now you could also just use let me pause the video here. Now you could also just use a random string generator, just define what sort of letters and numbers and characters really that would go into creating the password. That would take a little bit longer, with my cheap computer and just the time that we had here. Instead, I used a Word file of passwords, and I just made sure that my password was in there. Again, there's 14 million passwords in this Word file. If my password didn't reside in there, then it wouldn't find the password. It has to be in this file in order to crack the password. So I put my password about 6 million deep into this 14 million long list, and yeah, it was able to crack it. So I'll show you that here. And the command that I'm running here, this is sudo aircrack ng. We go -A2. What that does is it defines the attack. So the A is the router, and 2 is for WPA router. If I put 1, it would be for a WEP WEP router. And again, that -B, that's for my MAC address for my router. The -E is for the SSID, the name of my router. This -W, that's my Word file. Again, this is 14 million different passwords in there. And this test do pcap, that's actually handshake.pcap. This is the file where that handshake took place. So yeah, it's going to run now through all those 14 million different passwords in that file, and you can see up here that it is just going at it, and it's just going to run until it finds it, or it'll get to the end of the file and it'll say that it could not find it. Now, I actually, just because I'm putting this up on the internet, I don't keep this going so you can see my password. But yeah, that's what it does from here on till either it finds it or it hits the end of the file. It looks for passwords. So yeah, I stopped the video there, and I just wanted to show you that I did get a success screen here. Key found. Very nice. And yeah, it took about 30 minutes to find it, but again, that was a file of 14 million different passwords, and it was able to find it. So yeah, that's how we decrypt a password from beginning to end. So learning about this brute force cracking of the WPA password, it really reminded me of a technique that I picked up when I was like 14 or 15. And trust me, I never use this for bad, but I learned to pick locks, this basic lock picking technique here. It's called raking, like you would rake your leaves in the fall. But yeah, basically how it works is you look at the lock here, you apply a little bit of pressure as if you were like turning a key in a lock, and then with this device the gentleman has here in his right hand, you move it back and forth in that key chamber until these pins line up with the chamber, and then you can turn the chamber as if you would a key. And so really it's just kind of a brute force method. You're just pushing this in and out and up and down, trying to randomly get these pins to stick in there at the right moment. And once they all line up, you can get in. And yeah, this works with any sort of cheap lock, like padlock, that sort of thing. And yeah, just a good analogy for what we're doing with this brute force WPA cracker here. So before I talk about how it works, I just want to quickly expand upon what the four-way handshake is before we talk about how it breaks it or cracks it. So the point of the four-way handshake is that we have our router here, the AP, the access point, and we have my iPhone, the STA, the station, and they're going to talk to each other again, but they both first, before they start transmitting packets, they need to prove to each other that they both know the password. So what the router will do is it will make up a random number. I think it's a 256-bit number, um, and it will encrypt that and send it in an anons. What that stands for is A is for AP, so that's the access point. N is for number, and this is once, so it's an anons. Sends it to my iPhone. And what that does is it'll create what's called a pairwise transient key, and basically that's created by like concatenating, the original password, um, the a nonce that was just sent to it. It's going to create its own nonce, what's called the S nonce, and it'll also concatenate to that the MAC address for the router and the MAC address for the iPhone itself. And so it'll send that back to the router with a frame on it to protect it. That's what this mic is here for. And yeah, I wouldn't be able to decrypt and send this back successfully unless it actually knew the password. So once the access point gets it back, it'll know whether or not it knew the password. It'll construct its own pairwise transient key, and what it'll do is it'll send back a group temporal key, plus another frame here to protect that. And what this does is it just keeps any malicious actor in between from manipulating it. But yeah, it sends back this group temporal key, which will then be used with the iPhone in order to decrypt traffic between the two. So now, whenever they're sending packets to and from each other, like when you visit a website or anything like that, this is the key. This GTK is what it'll use to decrypt that. So now that I kind of walked you through kind of an overview how that process works, let's just talk about really quickly how we break or how we crack the password with that. So how we crack the password from that four-way handshake, really what we need to do is we need to get some information first from the handshake, from the four-way handshake. So what we're looking for is we're looking for the MAC addresses, both for the router as well as the iPhone. We're looking for these nonces that they sent back and forth to each other, as well as we're looking for this MIC frame here and the fourth frame. This is the most important one here. Okay, so basically what we do is we will take a candidate password. So we'll open up our dictionary of random passwords, and we'll pick ABC123, and from that we will use that to compute a pairwise master key, and then we run through the process of encryption, of possible encryption from the handshake. So we'll create a pairwise transient key from that made up ABC123, and the router MAC address and the iPhone MAC address and the nonces. And then we'll basically run it through this pseudo random algorithm that changes it, and it will compute its own MIC frame. And if that MIC matches the one that was sent initially, the one that we gathered from our step one, then that's the correct password. If that match occurs, then we know that we have the password. And that's how you break it. So how do we best defend against this sort of attack? Really, the easiest way to do it is just to change your password to a passphrase. Most of these password cracking algorithms, they kind of break down once the passwords get longer than 10 characters. They'll take too long. So create a passphrase. It has a lot of benefits. It's easier to remember, first of all. A lot of my girlfriend showed me this comic here that I had not seen before, but a lot of people will try to obfuscate their password by just introducing some weird characters, like instead of an A, putting a 4, or instead of a O, putting a 0. But to a computer, that doesn't matter. It just sees characters. It just sees on and off switches. So it's not going to be fooled as easily by that. However, if you increase the length, if you create a passphrase, then that is much more effective. It can take 100 years to crack a password that is very long. So that's the easiest way around this. Best lesson that I learned from cracking my password. So that's going to wrap it up for us here today. If you have any questions at all, go ahead and just email me here at michiza@oregonstate.edu. Thank you for sitting through this video. I apologize if my voice sounds annoying. It certainly does to me. It sounds annoying to myself. But yeah, I hope you have a good day. Take care.